Hello, and welcome to Sean Builds a Lisp. My name is Sean, and I am building a Lisp. So last time we went through and we were trying to make our macro expander hygienic, and in the process I decided that I actually needed to be able to define new macros in order to continue working on that. So I built a quasi-quote form, and was none too happy with how complicated stuff got. So if I can remember where that file is, I believe we're in our expand test. And so basically, as we're quoting, what I was doing was generating like Babel AST node to represent a Babel AST node. And so basically, this is what syntax quote was expanding to, and that is just a lot of nonsense. And I just didn't like how complicated it got and how difficult it was to understand what was actually happening. So I was thinking about it over the last week and kind of came up with an idea on how we could restructure everything, make everything a little more obvious and a heck of a lot easier to work with. So today I'd like to just kind of go through and give that a shot. Now, totally not sure if this is actually going to work out the way that I think it will. So what I'm going to do is I'm just going to kind of do everything in line. Normally I write tests as I'm going and all that stuff, but I kind of want to just play around. So we're going to be fairly freeform today. Okay, so let's get started. I'm going to go ahead and open up my compile.js file, just because I know that it's a file that's over there. It won't mess with anything if this doesn't go how I want it to go. So I'm just going to write a bunch of stuff in line, and we're just going to be working with this file today, unless things go spectacularly late, and then we'll refactor. All right, some random breakpoints, great. Okay, so the whole concept of this refactor, I suppose I should explain that. Let me start out by actually opening our expand function. So what we were doing before was, find my expand, is as our reader was returning Babel AST nodes directly, it was returning array expressions, and it was returning a new AST node symbol literal that I made, and string literals, and whatnot. And so part of the problem is that we have this kind of dichotomy between, we have arrays, which are our S expressions, and then we have Babel AST nodes, which is what we're ultimately expanding to so that we can generate our JavaScript. And so basically going back and forth between arrays and objects like this was just, I think that's where the confusing part was coming in. So what I'd like to try doing is making everything, all of our nodes, our primitive forms, not our primitive forms, but the built-in forms will be actually array subclasses. And so what that allows us to do is kind of, when we're working in our programming language, BLisp, we can totally work with things that look like that are arrays. Essentially, we can index them just like we would expect index S expressions, and then when we get to the code generation, that's when we will expand those into Babel AST nodes. So let's get started. What I'm also going to do is I'm just going to require the Babel types library. And so this Babel types library is just a set. It's a set of builder functions that help you build Babel AST nodes. And so I'm going to open up the TypeScript definition file for this. And so we're just going to kind of be following this. So basically, for every node in this file, we're going to make a class that extends the built-in JavaScript array. So at first, I'm just going to start with kind of the main ones that we need so that we can get something compiling. All right, so I'm going to make a class call expression. Oops. And that will extend array. And so this is going to be a pretty common pattern. Cool. Let's make another one. So call expression is going to be a root primitive. When we parse an S expression, that's what we're going to be parsing into. Let's get a member expression. So we're basically going for a hello world type thing right away. And we'll see how that goes. Okay. So what I want this to look like is essentially get some object, and we're either going to, we probably need a quote, but let's just keep going. We'll do that in a minute. All right, so if we were to compile this, I would want this to be a member expression. And so I'm using some kind of weird notation here. So this is the member expression class. And so we want this to be identifier get. We'll need identifiers also. Identifier foo. And then this is going to be like quoted identifier B. And then from there, we'll expand this to a Babel AST node that would essentially compile to that. All right. I'm just going to spread this out a bit so that, you know what, I'm going to turn this into a block quote just for my own sanity. And let's just kind of make it look a little prettier. Okay, so to get started right away, let's see, we'll need an identifier, and this won't extend anything. And then let's do a string literal, which we're going to extend string. So even our strings are going to be classes here. So what we'll do is we're going to essentially just oop the heck out of this, and we'll include compile functions on each of these. So inside our compile string for string literal, we're going to, actually, let's just call the, all right, t dot string literal, we'll just call the Babel AST function, dot value of to pull out the inner string. All right, so compile here, we will return t dot identifier, and so we need some kind of identifier. All right, so we're going to make a constructor here, ID, and then we'll just assign that to the class. So we can pass that. All right, and so for value of, we want to basically, when you call value of on one of these classes, you kind of get the primitive JavaScript object. So for a string literal, when you call value of, you should get the string that it represents. So for identifier, what I'm going to do is I'm going to return an intern symbol, just so that we can differentiate it between a string. So it probably will also come in handy for lookups later on. Excuse me. Okay, cool. So member expression. When we compile this guy, what we want to do is return member t.member expression, and our object will be, now remember, this is essentially the first element of the array is going to be the get symbol, and so that's the symbol that it's referencing. That's actually like how we're going to generate this. And so the object will be at index 1, and then the property will be at index 2. And for now, we're going to ignore this whole quoted thing until we have something running. All right, so for compile, for call expression, what we're going to do is, all right, so callee will be at index 0, and then our arguments will be the rest. Another second optional. I'm not sure what the rest of these things do, but we'll get there. Okay, so now we have a call expression, a member expression, and an identifier. And so identifier and string literal. Now, this is, I think, all we need to actually compile hello world, just like we did before. All right, I'm just going to kind of keep this in line, but I want to basically mess with this compile function. It's not actually referenced anywhere, so it's fine. Okay, so so basically we're just gonna check the we're just gonna check the class type of syntax, and that's great. So oops, sorry, talking and typing end up doing the wrong thing. All right, so if it's a call expression, we're going to, oh, you know what? I should just call compile, and as we're recursing through, we need to go ahead and call compile. Okay, that's fine. String literal, it's fine. All right, this dot 0 dot compile, and so we're gonna map this with compile. Oops, no, we can't do that. We need to actually do it. Let's just call it param, because that's what it's kind of called, and we'll just call param.compile. Okay, so actually compile is really simple. We're just gonna return syntax dot compile. Okay, so let's get something to actually compile. We'll just call this form, and so let's just do something simple. We'll do new call expression, and our arguments are going to be first the object. So we'll do new member expression. Oops. And wait, what am I doing? Okay. And our member expression, our object that we want, is going to be an identifier for console. And the property will be an identifier for log. And then we have our arguments. So let's just do new string literal, and that will be hello world. All right, so now that we have our form, let's just log it out, and I'm just gonna just run this file. All right, so we're just gonna run this file in Node. Compiler / compile.js, and let's just see when we log out. So we log out. It looks like it worked. Cool. So we have a generate. So let's just grab, let's compile. All right, okay, so we made our form. That's great. We need to now compile it. So let's call compile on our form. And let's just log that out as well. Okay, let's see what happens. Okay, so we crashed. Property of call expression expected node. Oh, that's interesting. What are we doing here? Call arguments. Oh, you know what? Okay, so we actually need to also compile. No, this seems like it should work. All right, well, I think that I can just pretend like I'm running a test and hit a breakpoint here. Let's see. We've got a bunch of Mocha stuff wrapped around it, but it should still just run the file. Okay, great. All right, so let's see. This dot slice 1 dot map param dot compile. All right, so now, I mean, we have an array. Babel should not care that this is a call expression. Okay, I'm just going to continue running and let's just see what's going on. Okay, so we have a type error because we're not valid. We have an undefined thing. All right, let's see here. Let's look at node. This is probably still undefined. Call expression arguments. Oh, what? Oh my goodness. I think where are we? Compile.js. Param.compile. Interesting. Oh, here. I didn't call this. Oops. Okay. Cool. I'm just going to go back to the terminal and run that in node. Okay. Making some progress at least. All right, so we expected a string. But got null. Property name. Expected type of string. But got null. Oh, okay. Oh, I didn't actually assign it. Okay. Here we go. We're waking up. Let's run it. Compile of undefined member expression. We didn't. Oh. All right. Let's see. Oh, our AST is totally wrong, right? Member expression. This has to have a get. Okay, that's better. Okay, there we go. So here we have our Babel AST. So let's see if we can actually generate some JavaScript from that. All right, so we're just going to call generate. So again, this is the generate function from the @Babel generator. So giving the generate function some Babel AST. All right. So let's see, generate, and we are going to feed it the compiled, and then let's just log that bad boy out. Okay, let's run that and see if we get some JavaScript. Look at that, console.log hello world. Okay, and then shall we just eval? Let's just eval it. All right. We probably want an exclamation point there. So that was pretty cool, right? So what shall we do next? All right. So the next thing I want to do is kind of get this quote business out of the way. So what we're going to do is we're also going to write an expand function in line here. So, and all right, so this is going to look pretty similar to the expand function that we already have, but just be a little bit simpler. Okay, so if our syntax is an instance of a call expression, then, oh, come on. There we go. No. Eventually, I'm going to get my bracket set. Okay. I'm also going to inline just make a resolve function as well. For now, this is just going to be very simple. We're just going to look up the value. We're just going to look up in the end. So later we'll go back and get our scopes going again for hygienic macros. But okay, so let's pull the first one out of here. And what we'll do is we will just gonna go ahead and call expand on syntax 0. All right, so the first element of the call expression. All right, so if we get a function, then we're gonna call the function. Okay, so this format will be the same as pretty much all of our previous expand function. So we will call first, we will want to return first, and we're going to pass it the syntax and the env. So I think I want to rename syntax to form because we are not really working with the traditional syntax objects from before. Oops. All right, so I'm just doing a search and replace on syntax to form. Okay. All right, so for now, we're going to leave that as is. And if it's not a call expression, then we're just going to return the form itself. And then, so now that we have our compile, we have our form, what I want to do is make an env. All right, so symbol dot for get. So I'm going to essentially call this member expression into a macro. And so this will be a function that takes a form and an env and return something. So we're going to return a new member expression. And this will work by first argument is simply our get. So we can just pass form 0. And then what we want to do is expand each of the rest of the arguments. So we'll do form.slice 1, and we will map. Let's call this inner form, and we'll return expand inner form with our env. Okay, looks like I have a syntax error someplace. Let me find that. Oh, just need an equal sign here. We're assigning something. Okay. So basically, we wrote a macro get that will return our member expression. So now I should be able to return this into a call expression. Oops. And what we want to do is expanded equals expand our form with our env. And then we want to compile our expanded. And let's just go ahead and log out the expanded form so that we can trace everything. And I'm just going to run this in the terminal again. Let's make some space. First is not a function. It's interesting. Seems like it should have worked. We didn't pass our env. Okay, let's run it again. Still not a function. Okay. Well, let's debug it. Okay. Oh, we need to resolve it. Okay, so if first is an instance of identifier, then I'm just going to reassign. This is kind of hacky, but it's just, we don't need it again. We will resolve first with our env. And again, we're just looking this up in the map for now. We're not worried about hygienic stuff. Okay. Okay, we're just going to run this guy. Okay. No idea what's going on, so we'll just pause. All right, so. All right, let's see here. Okay, so form is a call expression, 0 is a call expression. Oh, right. Okay, we need to just go through and expand everything. Oops, form. All right, so form.map and so what we're gonna do here is we're just gonna go ahead and our end. So basically, if it's not a macro, then we want to expand anything that's inside. All right. Oh, look at this. If first is not a function, call it. There's the bug. That was not equals instead of equals. All right, let's just run this in the terminal. It's way faster. We'll see. All right, cool. We have another crash. Eventually, we'll get all this lined up. Let's see. Okay, what is this? Hold on. Okay, let's back out here. What is what's happening? Totally confused. All right. Okay, I think, oops. We need to, let's look at our expand function. We're only doing stuff. if it's not a call expression, then we'll simply return the form. And okay, just a normal JavaScript thing. Run that. Okay, we got much further. Let's see. And it worked. Okay. So now that we have that, so basically, where are we in our call expression? I want to also build in quote right away. So if you remember, I want to essentially, if you're quoting the argument to get, then that will compile to member access. Whereas what I'm going to do is just copy all of these lines. All right. Whereas if you were to do something like this, then we want this to compile to like a computed property. So what I'm going to do is I'm going to make a symbol. All right, so const quoted, no, not new symbol, but we're just going to make an internal symbol that we're going to attach to these objects. And we'll go to our env. Here it is. For if we have a quote, then we will return form. And for now, I'm just going to do something really dumb. I'm just going to modify this form in place. And I will set quoted to true and return the form. All right, so inside member expression now. So I'm doing all of this in line just as a reminder that I'm not sure that this is going to work out. So all right, so basically, what do we need to do? So we've got our macro, and then so if we expand quoted form, we should get back the original quoted form. All right. So where's our expand function? I'm almost tempted to make this a totally separate class, but we'll see. So let's just check if form.quoted return form, and we will just kind of unquote it. Okay, so now in get, actually, I'm gonna just go ahead and run this and see what we've got. Let's just put a breakpoint here and we'll run. So all right, let's see what expanded is. All right, let's just gonna make terminal big, and let's see. Expanded. Okay, so we have a call expression with a member expression. identifier get console and log. Oh, I forgot to quote log. The whole point is that I wanted to quote this. All right, so new call expression, and this will be new identifier, and we will simply quote this guy. All right, and let's rerun. Okay, let's get the terminal up here. So as I was thinking about this, the whole quote thing was the one thing I wasn't so sure. Okay, so we have quote and log. Okay, I think my expand function here is not quite what I wanted. We want to say form the second element in the quoted form is what we want to toggle. All right, I'm just going to rerun that. Let's just make sure. So basically what I'm looking for here is that we get our quoted identifier out, which I'm, oops, shoot. What was this? All right, let's rerun. I'm not sure what I did. Close that. While we're waiting, just close some of these other guys here. Okay, I want to step over, and let's expand. And let's just put that out. Let's look at our member expression. Oh, we still have call expression. Quoted, not quoted. So basically I was calling quote, but it was saved in my env as quoted. So normal everyday bug. All right, let's look at this. Expand our member. Great. Okay, so you can see that our identifier is, and we're just kind of tagging this as being quoted. And so that's kind of mainly going to be a hint to the compiler. I don't expect this to actually really be used all that often. So I'm not sure how I want to do this, but I think that the form of member expression, like this pattern, I definitely do want. So I'm just going to continue along these lines. All right, this is going to get a little crazy, but basically this this third parameter to member expression is if it should be computed or not, and so we want this to be not this one is quoted. So if it's quoted, we want it to be. If it's not quoted, we want it to be a computed property. Otherwise, it should be a dot. All right, let's rerun. Breakpoint moved on me. Okay, continue. Whoops. Oh, look at that. So we have the wrong thing. That's great. Wait a second. We did quote it. Something is wrong. Something is wrong. Oh, we're expanding it again. So basically, when we get in here, okay. Oh, wait. Okay. So we call get. And what we're going to do is go through, expand the inner form. And at this point, that inner form is quoted. So we should get a quoted guy out. Okay, I'm just going to rerun and step over. Step through everything. Well, step over everything. Okay. Let's look at our expansion. Member expression. It is quoted. I'm going to jump into the compile for member expression. All right, so this is also pretty great. Thing that I like about this is that it's going to be a lot easier to just hit breakpoints here. And it is. Let's just see. Is it true? It's true. Oh, it's 2. It's the second argument is what we're doing. All right. So I think that was a bug. All right. Let's rerun. Okay. So now we got what we want. So this is kind of working out. The quote form, I'm still not happy with. It's still too weird. So I'm wondering if we should go back to kind of having a difference between symbol and identifier. Okay, what I'm going to do is I'm just going to put a breakpoint here, rerun, and I'm just going to kind of think about this and see if this is what we actually want. Okay. All right, I'm just going to log it here. And what do we got? We have this. We just want to... Let's see here. All right, I'm gonna try that and see how I feel about it. So we're going to bring back our symbol literal. I don't know. Shall we try? I'm gonna just try this and down here. Let's I'm gonna try extending symbol and see if this does what I am expecting. So basically, as we're expanding things, if like quote is essentially says stop macro expanding, stop expanding things. So if we quote an identifier and we just get the identifier back, we're not really sure what we had. We're not sure that it was quoted to begin with, and I don't like the idea of having this flag for quotes. But we need to be able to compile things differently. So I'm just going to try and see if I can do this. What? Okay, well, that's a bummer. All right, I'll just do it here then. And let's just decompile. All right, so what we want this to be, this is going to actually be a new expression. Right, okay. And what's the call E? The call E will be symbol, or sorry, symbol literal. Arguments will be t.call expression member expression, and object will be an identifier, which is symbol, and object will be an identifier, which is for, and oops. Arguments will be, oops, wait a second, symbol for this dot value of, and we'll do symbol dot key for. Whew. Does that make sense? This might be. Okay, and then in our expand function, we'll also want to check for that. So we'll do an else if form is instance of symbol literal, and we will return an identifier. Symbol dot key for and form dot value of. Let's see, does this make sense? So it solves our immediate problem. All right, so all right, Oh, we have to, now we're calling expand again. Oh, sorry. What we want to do, this is all right. So let's look at our env here. I think this is probably where we want to do this. Okay, but I don't, so with these built-in primitives, I don't want to modify the actual form. But so basically we need a place to store this. What if we just do something stupid like I don't think I like this either, but let's see. All right, I'm just gonna run and see what we end up with here. Oh, we didn't actually do this. All right, so if we quote, our quote form needs to get a little smarter, right? Okay, where's our end? This quote. Okay. So basically, quote just does nothing. But it stops the expansion. Okay, I'm gonna look. What is this again? Oh, it's here. All right, so we've got a bunch of identifiers. Oh, that's interesting. Oh, right. The whole point was to swap identifier for symbol literal. Okay, this isn't quite as clean as I was hoping it'd be, or as okay. Oh, we need to go wrap these in symbol 4. Okay, I don't think I like where this is going. Okay, I'm just gonna go ahead and rerun. Let's see. Oh, symbol is not a constructor, of course. Bummer. Okay, so we can't extend symbol, but we can make something that looks a heck of a lot similar. And we'll do value of and just return our. Okay, and I'm gonna run that. Okay, and now what is this? This is a symbol literal. Okay, so now we're going to come down here and compile. Okay, just for completeness, let's just see here. Instance of, I think I'm probably just getting a little ahead of myself here. Sorry, I'm stopping, just kind of debating in my head if I am okay, like making member expressions such a special snowflake. I'm not sure. All right, so we definitely, let's just make an identifier for this symbol. We want symbol key for okay. I mean, it might be okay that this is such a special little snowflake. Oops, sorry, that's not done. All right, so basically this is computed unless, oh, you know what? This is probably what keywords are for. Yeah. Okay, so I think, all right, let's continue. Computed, and this is basically not instance of symbol literal. Oops, I was not paying attention. Wait, what is this? Symbol is to value of, we actually want to call that rerun. Oh, let's look at return object. Return value object is an identifier, property is an identifier. So this did work. It's just not what we want. I think we actually, so in Lisp enclosure there are keywords. And basically symbols, let's just talk closure because they end up being, they look very similar, but they're slightly different. So in closure, you have a symbol, and basically when a symbol's, this could also totally be wrong. If you're out there watching and know closure better than me, I apologize. But basically, a symbol gets evaled to a variable, and that variable is what is actually doing things. And a keyword enclosure evaluates to itself. And so basically, if you call val on keywords, you'll always get the keyword out. So I think this is probably how we should actually go about this. And so what I'm doing here, I'm actually like into programming, the real programming language now. We're not like building like infrastructure like we have been over the last few, over all the episodes up to this point. Right now, I'm deciding the semantics of the programming language that I am building. So if we call this, I don't think this is basically, I think probably what we want is some identifier. So I think basically, you know what, let's just go look at the closure docs. I mean, let's see. So I'm looking at map because I'm kind of model objects after the closure map. And so let's just see how this is, how you actually use maps. And this is just, oh, this is the map function. I want, maybe data. Okay, not used to navigating this. Okay, we probably want to trans value map to key not found nil at present. Oh, there we go. Okay, so sorry for being quiet. I am just kind of scrolling through here, reading. Let's try REPL. Let's just try REPL. Do I have to log in? I've definitely done this without logging in before. Or not. Might have changed it. Maybe I could just deep link into it. All right, so I'm just gonna kind of poke at closure and see what they do. All right, if I remember, I don't remember my closure. Let's just do something like this. I suppose, let's just make these different so that we can tell what's going on. Okay. And then get a foo. What happened? Run. And if we say get a foo, get Baz. Okay. I'm gonna see if I can. I don't think this is going to map exactly one-to-one. I'm just going to put another one in here. Okay. Okay, this is pretty fun though. We are actually worried about our programming language rather than parsing. Okay. Let's see. So the other thing we could do here is set up some kind of variable structure. Okay, so basically, as it stands now, a symbol will compile to an identifier. So maybe it's okay that member expression behaves this way. So the other thing that we could do here is kind of make this look a little more like JavaScript and have foo be compile to the dot form, and we could just say get foo be like this would compile to the access form. So would that make sense? I don't know. Maybe that's what I'll do. And then, so really the question is, if something has been quoted, should you be able to tell from the outside if a primitive has been quoted? So I'm actually gonna pop back over to the REPL here, and so if we have foo versus quote foo, let's see what happens. So you can see that you can't tell the difference. Well, that's a keyword. It always evaluates to itself, but if I quote a string, we just get a string out. And if we quote, actually, so if we have A, let's quote A. And so, of course, then this is making the member expression branch on do I have an array? Is my argument an array? This is also a much more common form, so maybe we want to make that easier. So basically, what else would happen? So if you wanted to call, I mean, this would match JavaScript. Maybe this is better. And that way, I think this is better. So what we need is an array literal. So we can just go make it. Actually, an array literal is just an array. Okay, and so you can, let's do this then. Okay, so rather than doing symbol literals, we'll stick with identifiers because I think it might match JavaScript better. Of course, we're not going to be able to match Clojure or Common Lisp perfectly in any of this because we're compiling to JavaScript. The semantics are different, even though they're slightly the same. And so, let's see here. So I'm going to go ahead and put this back in. And so this is not, I don't think I really expect this to be exposed to the outside world. I think this is really a hint to the compiler that if a form is quoted, then it needs to be compiled to JavaScript in a different way. Is that true? Maybe that's not really true. Yes, it is. Okay. Anyway, let's continue. All right, so with member expression, what we're going to do is, all right, so let's see here. If it's an array, then we will we will compile the first element, and otherwise we will compile the element itself, and then, oops, sorry, and then this guy, we need to compute it if it's an array. So if we go back to this, rather than quoting this will just be an identifier, and it'll look like you expect it to from JavaScript. We don't want to call that. All right, I'm just going to run this in the terminal. We should still get everything out. Oops. Where are we here? 111. Oh, didn't I just delete that? Oh, what's happening? New. Okay. Okay. So let's all right, so I'm just going to comment that out, and let's do something weird. All right, so actually this guy can just be an array, and our items will be a string literal. Log. Okay, so basically what this should do is compile to console log foo. And so just kind of doing some tests in line. It won't. Oh, holy moly, that did work. Look at that. Okay, so that worked. If we had a function, it wouldn't work. Okay, let's just go ahead and do that. Let's make a function foo that will return the string foo, and we'll call that from inside here. And yep, so oh, that's it. That's our call. And close that. Okay, so this will compile to console log or console get foo, which we want this to return log, the string log. So when we eval it, it will call the function foo, which returns log, which will ultimately return our console.log. So this is a totally contrived example that we will see worked because it was a call expression. Okay, so it's still simple enough. All right, we need one. No. Okay, what I was getting at is our expand function needs to handle arrays. So if we find expand, if our form is an instance of, whoops. We're just going to do this array. Then we will return element, and so basically what we want to do is expand each element inside of the array, but it will still be an array. And so you can call expand on arrays many times and you'll always get the same result. So element and env. Okay, let's see. Okay, so this will all work, and so I keep going back to thinking about how a quoted identifier is just just the same identifier. So the other option we have is to I'm gonna go back to the REPL, closure REPL, and just kind of poke around and see what the behavior of various things is. So let's just do I thought that's what that was called. Oh, maybe there's a dash. Okay. Okay, I'm really not sure what I want to do here. I think that we can probably just continue. All right, so what happens to a quote? Okay, so let's pretend that we were actually going to write a macro. And what would happen? Okay, so let's call new call expression, new identifier, quote. And then we'll do a new, actually, you know what would be awesome? Let's just, okay. Let's just wrap this whole thing in a quote. And so we're just gonna quote our whole thing. Quote, and okay, so I am going to stop here, and I'm just gonna run this and step through and just kind of see how the system we've built behaves. Okay, so we'll log out our form. Let's log out expanded. And so what do we have here? Interesting. Literally nothing. It's the same thing. Oops, we crashed. Okay, where are we here? That's not slice one. What is this? Oh, we do need an array literal. We can't just use array. Array, actually, let's call this array expression because that's what Babel calls it. Because we need to attach a compile function to this. So we'll return t dot array expression, and this is an array of elements. So we can just do this dot map compile. Oops, whatever. Okay, so this needs to be new array expression instead. Actually, let's just make this an identifier log again. We're kind of have moved on from member expression. Oh wait, what is this? This is not where I was. I want to go grab my form. Oh, look at that. I copy pasted this so that I could toggle between these two things indiscriminately. Okay. And my breakpoint got moved. Shoot. Get what happened? Okay. I'm going to rerun because we just kind of skipped over everything. We don't need that one. Okay. It's all right, so compiled is the thing that we are looking at. All right, so basically, if we were to write a macro, we would want to use quote. Let's say that we were just trying to write a macro that would literally return the program that we just had. And so we would quote it, and basically we would expect that to compile to something that returns the actual call expression. Okay, so I'm just kind of thinking through what we would want. So essentially, what we want quote to do is spit out this as JavaScript. Okay, so I think I'm kind of thinking more and more that like quote is a thing. It's a base primitive. It will stop compilation. And okay, so let's do it like that. And then, all right, so what are we gonna do here? So class quote extends array compile. Okay, so now interesting. Oh, we're still here. Let me just see here. Call expression. All right, so let's see. Boom, boom, boom. So our form is call expression. Actually, what happens? Call expression from form. Okay, so basically what we need to do inside quotes compile is we need to look at the type that we're compiling and essentially like we want to just map it to a bunch of new calls and then compile that and then make that the JavaScript. And so the whole point of this is basically so that like everything inside of the programming language kind of operates with the same object or the same structure rather than switching to and from the Babel AST. And so quote basically quote's a built-in form, so it's not really something that I think you should be able to inspect. Maybe you can. Anyway, let's see. So getting back on track, quote is essentially its argument will be some class, one of these classes, most likely call expression or primitive, and we need to call new on it. And so how do we do that? So new, I'm gonna basically, let's see. So we have a form, which is a call expression, which is actually what we're trying to quote. And so we have a constructor. I wonder if we can just do new form dot constructor. Oh my. Okay, so this is a little tricky. So basically, when you're in this compilation environment, we don't have like, there's compile time and then runtime, and so like you compile something down and you have a function that returns a quoted form, and so at runtime, when we call that function, we want that function to return these objects, but we don't necessarily have access to the object at runtime. We certainly have it at compile time. Bummer. This might not work. Okay, well, that's why we were experimenting. Okay, so basically, okay, I'm gonna have to take a moment to think this through. Okay, yeah, I think this isn't going to work very well. So what we were doing before with quote worked because we essentially had the Babel AST nodes are just plain old objects, and so we could simply make one out of nothing. But in this case, we need to compile to something that has access to our classes at runtime. So I just don't think this is gonna work, because then when we compile the script, it needs to somehow inject these these classes, and we could assume that they're available on the global. Like we could have our compile compiler environment attach all of these classes to a global window. That's not great though. We could attach them to the env. Let's see. Maybe that's the solution. Let's try that. So basically, for every one of these classes, we just need to attach it to the environment. Where's our environment? Here we go. So call expression. Identifier. String literal. What else do we have? Okay, so then what we can do with quote is basically loop over everything, calling the constructors. All right, let's go find our quote form. It's quote. Oh, but we're going to be inside a macro. Sorry, I'm lost. Where's quote? I didn't make one. Okay, so let me step back and walk through that. My thought process was I could take the class constructors, attach them to the environment, and then quote will be expanded inside the environment. So no, it will be expanded inside the environment, but not necessarily at runtime. But we could restrict quote to only use in macros, which will be called inside a macro function that has the environment. The problem with that is that you're inside a user macro function. You don't know what they call it, what they bound the environment to. Okay, maybe this just flat out won't work the way I want it to, which is a shame. Okie doke. That's a bummer. Well, I guess been going for a couple hours here. I think I might call that a stream. I think I need to think this through a bit more. All right, well, maybe I will be back later. Otherwise, as always, thanks for watching, and until next time.